This is a hidden quadratics question. We've got some horrendous sort of powers being added together and stuff. It's got to be a hidden quadratic. So let's do a substitution. Let's t, and you can use anything you want. You could use x, but I'm going to let t equal y to the power of a quarter. That means t squared is going to be y to the quarter squared, which is y to the 2 over 4, if I multiply those two together, which gives me y to the half. And that's great because that's what we need. We can now write down that it's 2t squared minus 7t plus 3 equals 0, and we've turned it into a quadratic by substitution. Let's try and factorize it now. So if this is going to factorize, we're going to have a 2t and a t in some order. Makes sense to just put the 2t there. And then I need the two numbers to multiply to give 3 and add to give minus 7. The only way that could be the case is if they're both negative, but I'll ignore that for the moment. Then I'm just going to try some numbers out. So I might try a 1 here and a 3 here, because 3 is quite a small number, so it's either going to be 1 and 3 or 3 and 1. Okay, if I multiply these, I'm going to get 6t, and if I multiply these, I'm going to get t. And that's going to work. If I make them both negative, then I'll get my positive 3 when I times them, and I'll get my minus 7t, so we've done it. Okay, so it's either this bracket is 0, which means t is equal to a half, or this bracket is 0, which means t is equal to 3. Let's just remind ourselves that it was y to the 4, so that is the 4th root of y, is equal to a half or 3. So y is going to equal a half to the power of 4 or 3 to the power of 4. And if we raise this to the power of 4, it's going to be 1 to the power of 4, which is 1, 2 to the power of 4, which is 16, or 3 to the power of 4, which is the same as 9 squared, which is 81. There we go. That's the answers.